Back to this series of lectures. So we have a right angle triangle ABC, which is right angled at angle C. Okay, having length 3, 4 and 5. Now the question goes like this: if the hypotenuse slides on the coordinate axis, so the endpoints of hypotenuse AB slides on the coordinate axis, we have to find the locus of point C. So basically this is like a laminar plate which is sliding on a coordinate axis with their points A and B, right? So let's take some other situations. If I take this length as 5, so now of course the point C will go somewhere else. For some other situations, third situation, if this ladder length is still fixed, let's say B and A, so if we'll take a snapshot at different configurations, this point C will try to move on some curve. We have to find the locus of point C, which means the relation between x and y coordinate of point C. Okay, so pause the video and try to think over this. It's a very beautiful problem. You might have done the problem, thought starts from this. You might have done a problem where there is a ladder of length, let's say 1, slides along the coordinate axis, and you have to find the locus of a point which is midway between them. So just by taking some of the configuration, you can easily feel like the ladder is going to go in a circular arc. Okay, so this is just a feeling, but mathematically you can take a point, midpoint to be x comma y, so that gives this distance as 2a, this distance as 2y, because you can take this point to be alpha comma 0 and 0 comma beta. Okay, and then using midpoint formula we'll get this 2x 2y. If we'll square and add, the distance is fixed. Okay, length of ladder is fixed, so it's non-elastic ladder, and that will give you a value x square plus y square equal to 1 by 4. So this midpoint. Okay, so these questions we have already done before. Instead of midpoint, if you have any offset point, let's say a point which is divided into some lambda is to 1, where lambda is maybe half, 1 by third or whatever, we can still do the problem and we'll get locus as ellipse. If this ladder slides in all the quadrant, then of course we'll have full circle, okay, or full entire ellipse. Now how to go about this problem? So in order to solve this problem, let's draw the diagram first. So we have angle C over here, it's 90 degree, point A and B is 3, 4, 5. We need to relate x comma y. Now from the diagram, it's quite clear that since angle C is 90 degree and the angle at origin O is always 90 degree, so we can clearly see we have a quadrilateral AOBC, right? We have a quadrilateral AOBC. Now this quadrilateral AOBC is cyclic because sum of opposite angles is 90 degree. What does it mean? It means like we have a unique circle which is passing through all 4 vertices. So at a particular location C, if you will fix value of C, A and B, and of course origin is fixed, then we'll have a unique circle passing through all 4 of them. Now as this ladder slides, so maybe in a different configuration, as ladder is here, we'll have another right angle triangle over there. So still now we'll have another circle which is passing through this. So this circle itself is changing circle. Why? Because the configuration is changing. The sheet of metal plate, you can imagine, is varying because AB is sliding, right? Now how we are going to relate x and y? Now we'll use a basic property of circles. So if I connect O with C, okay, what is going to be the slope of this line? So can we have some angle changing? Can we have some angle changing? So let's say if this angle is theta, right? This angle is theta. So on the same arc BC, we have angle CAB is also theta, right? 4 by 3. In triangle ABC, we have tan theta. Tan theta equals 4 by 3. Now what is tan theta? For triangle OCB, It's interesting because tan theta is nothing but the slope of the line joining O and C. So it's nothing but y minus 0 by x minus 0, which is going to be y by x. And that solves the problem. This guys will be equal, so y by x equals 4 by 3. Hence y equals 4 by 3x. So it was a beautiful solution for this problem. We'll also see the animation of this. If the triangle is sliding in other quadrants also, so we'll have other lines as well. So that equations will become y square minus 16 by 9x square equal to 0, because then the locus will be this entire line, right? So that will become y equal to plus minus 4 by 3x. So here is the animation of the problem, and to your surprise you can clearly see the locus of C is a straight line. I would recommend you, like before you have seen this solution, it was better like if you would have tried by yourself, then you must have enjoyed, because usually when we ask this in class they feel it will be some closed curve, but a straight line is very, like as you can see how beautifully C is moving on a straight line, which is y equal to 4 x by 3, and basically that's passing through origin, right? This line passing through origin. So as AB is sliding on all the 4th quadrant, we'll get both lines mutually. So I hope you must have enjoyed. We'll come with more sessions like